Hello everyone. Today we will discuss about the fundamentals of electrical engineering subject, fourth chapter, that is magnetic circuit. So what is mean by magnetic circuit? To know about magnetic circuit, we should first know about what is mean by magnet. So what is mean by magnet? Everyone knows the magnet. Yes, there is force of attraction and it attracts the metals. Yes, it is a piece of solid substance which exhibits a property of attracting small pieces of certain material such as iron, steel, and etc. So this is a piece of solid substance which attracts the other metals like iron and steel. So application of this type of magnet is we are going to use this type of magnets in PMMC instruments as a voltmeter, ammeter, in DC machine, in dynamos, we require these type of permanent magnets. Another type of magnet is called as electromagnet. So whenever an electric current passes through a conductor or a coil, a magnetic field gets developed across it and the coil starts acting as an electromagnet. So in previous lecture we have seen effects of magnetic effects of electric current. In that case we have studied that whenever we wound a coil on a material, on a metallic substance, on a metallic solid substance, we have wound a coil, and whenever a current pass through that coil there is production of magnetic field. That means magnetic fluxes are going to generate it. So the same case is happening here also. So that setup is called as an electromagnet. That means the magnetic material or that solid substance is getting the property of a magnet, and it will attract and repel the magnetic material. That means it is it is not magnetic material whenever current is not there, and it is going to act as a magnet whenever we flow the current. So this type of a magnet is called as an electromagnet, as it gets the property whenever we flow a current. So if a coil is wound on a piece of some magnetic material, then that piece will start acting as a magnet. This type of magnet is called as an electromagnet. And for examples or application of this type of electromagnet are as a field and armature in DC machine. We are going to use these type of electromagnet in DC machines, in transformer cores, in electric bells. In previous lecture I have explained you how the electric bells are working, and its principle is totally depend on the electromagnet. Buzzer, in solenoid valves, in electromechanical relays, and in all AC machine we require these type of electromagnet. So this is very important thing. We should know about an electromagnet, then and then only we get to know how the AC machine is going to work and how the DC machine is going to work, how the transformers are going to work. So we should know about the electromagnet first. So what is these electromagnets are creating? That is nothing but the magnetic field. But what is mean by magnetic field? The magnetic field is defined as the region near the magnet within which the effect or influence of magnet is felt. That means the region, वो एरिया रहेगा जहाँ पे हमें क्या होगा कि मैग्नेट का जो इफेक्ट है, उसका जो इन्फ्लुएंस है हमें फील होगा. दैट मीन्स देयर will be a force of attraction or force of repulsion near the area of magnet. That field is called as a magnetic field. तो वहाँ पे क्या होते हैं, magnetic fluxes होते हैं. That's why there is a force of attraction or force of repulsion. तो उस region को क्या कहा जाता है, magnetic field. ओके, सो इफेक्ट और इन्फ्लुएंस ऑफ मैग्नेट जितने एरिया में हमें फील हो रहा है, दैट एरिया और दैट रीजन इज कॉल्ड एज अ मैग्नेटिक फील्ड. व्हाट इज next definition is of magnetic lines of force. So just I have said that there are number of magnetic fluxes there. So magnetic fluxes are nothing but the magnetic lines of force. Magnetic lines of force means क्या हो रहा है, you can see this figure. यहाँ there is an there is a permanent magnet having N and S pole, and due to these poles there is a force of attraction and fluxes are moving from N pole to S pole. Yes, there is force of attraction and fluxes are moving from N pole to S pole. Why this is happening? So this is the force of attraction between two अनलाइक पोल्स. तो यहाँ पे अनलाइक पोल्स हैं दो, एन और एस, तो वो एक दूसरे को अट्रैक्ट कर रहे हैं मतलब वहाँ पे मैग्नेटिक लाइंस ऑफ फोर्स रहेंगी उनकी बीच में. सो दीज डॉटेड लाइंस आर नथिंग बट द imaginary lines and they do not have any physical existence, and these dotted lines are nothing but the magnetic lines of force. For the rectangle magnet, N and S pole have these type of magnetic fluxes or lines of forces, and for U-shaped magnet, horseshoe magnet, these fluxes are going to be like this from N to S. Yes, so these fluxes are totally imaginary. They do not have any physical existence, but they are there. They should be there, then and then only there is a magnetic field created. So what is mean by magnetic flux then? The magnetic flux is defined as the total number of lines of force in a magnetic field. As I said earlier, magnetic field means what? The region near the magnet within which effect or influence of magnet is felt. Yes, and magnetic lines of force means what? Magnetic lines of force are used for representing the magnet, or these are the we are using as a representation. रिप्रेजेंट करने के लिए मैग्नेटिक फील्ड को रिप्रेजेंट करने के लिए we draw magnetic lines of force, and whenever we add this total number of magnetic lines of force in that magnetic field, that is called as a magnetic flux. So single magnetic lines of force are get together and the total magnetic lines of force are added, and we can denote it by magnetic flux, and it has a symbol phi, and it is measured in a Weber. Weber is in we write Weber as WB. So this is nothing but the magnetic flux. So what we have seen here, there is a magnet. What is mean by magnet? What is mean by electromagnet? What is mean by magnetic field which is created by magnet? तो मैग्नेटिक मटेरियल जो भी होता है वहाँ पे मैग्नेटिक फील्ड क्रिएट होने वाली है, एंड मैग्नेटिक फील्ड कंसिस्ट ऑफ मैग्नेटिक लाइंस ऑफ फोर्स. मैग्नेटिक लाइंस ऑफ फोर्स, total magnetic lines of force is called as a magnetic flux. So these total all definitions are depend on each other. Yes, what is the next definition here? Magnetic flux density, it is denoted by B. The magnetic flux density is nothing but the magnetic flux unit area measured in a plane perpendicular to the flux is called as a magnetic flux density at that plane. That means B is equals to phi upon A. Means if we are calculating the magnetic flux in per unit area, that is nothing but the magnetic flux density. Means in that particular area or in that particular plane how much fluxes are there is calculated by magnetic flux density. Density here, density means what? Like how many fluxes are going to pass that cross or pass through that plane, or in that plane how many fluxes are there. So this we can calculate by formula B is equals to phi upon A. So these magnetic fluxes are perpendicular to the plane and its unit is Weber per meter square. Why Weber per meter square? Phi is the magnetic flux, magnetic flux have Weber unit, and as the in denominator area is there, so area have meter square unit. That's why the unit of magnetic flux density is going to be Weber per meter square, or is also called as Tesla. As this all things are invented by Tesla, that's why the unit of magnetic flux density is given by Tesla. What is next definition? Magnetic field strength is given by capital H. It is also called as magnetic field intensity. The magnetic field strength at a point in the magnetic field is defined as the force experienced by the unit north pole placed at that point in a magnetic field. So this is nothing but the magnetic field strength created by or experienced by a north pole placed in a magnetic field. Whenever we place a magnet in a magnetic field, so how much force is going to be applied by that north pole? That force is nothing but its strength. So it's magnetic strength. That's why this magnetic field strength is nothing but the magnetic field strength at a point in a magnetic field is defined as the force experienced by unit north pole. So this is the force experienced by the unit north pole at that point of is at that point in magnetic field. This is the force acting towards that magnetic field. It is measured in newtons per Weber. It is measured in newtons per Weber or ampere turn per meter. It have two units, newtons per Weber or ampere turn per meter. So we know the formula. Here we can calculate the magnetic field strength H with the help of formula. H is equals to ampere turn divided by length in meter. So what is mean by ampere turn here? Here we are calculating ampere turn by number of turns into the current flowing through that coil. That is also called as ampere turn, and length in meter is the length of that coil. Yes, so we can write Ni by, we can replace Ni by mmf. So what is mean by mmf? We will learn further in further definitions. Okay, so here what is the next definition? Absolute permeability. Absolute permeability is given by mu. Its symbol is mu. It is the ratio of magnetic flux density B to the magnetic field strength H. It is measured in Henry per meter. So here we can calculate the value of mu by B divided by H, or we can write this formula by modifying B is equals to mu H. So this is nothing but, here mu is nothing but absolute permeability. So whenever we have to calculate the absolute permeability, we have to divide magnetic flux density divided by magnetic field strength. What is the next definition? Permeability of free space or vacuum. So as we are saying absolute permeability, and related with the absolute permeability, there should be a permeability of free space, that means mu zero. Here this mu contains two mu, that is mu zero and mu r. As we have seen in electrical circuit, there is epsilon zero and epsilon r. Likewise, in magnetic circuit, there is permeability and absolute permeability. Yes, permeability of free space and relative permeability. So what is mean by permeability of free space? The ratio of magnetic flux density in a air or vacuum or free space is given by B0. Here magnetic flux density of air, vacuum or free space is given by B0 to the corresponding magnetic field strength H is known as mu zero. So mu zero जब भी हमें calculate करना होगा, so we should know the value of B0 divided by H. So here the unit of mu zero is again Henry per meter. As absolute permeability is have Henry per meter, then the permeability of free space is also having the same unit, that is Henry per meter. So here mu 0 is equals to B 0 divided by H. Here B 0 is nothing but the magnetic flux density in a air or a free space. What is the next definition here? As I said earlier, absolute permeability have both the permeabilities, that is permeability of free space and relative permeability. So relative permeability, what is mean by relative permeability? Then it is defined as the ratio of magnetic flux density B in a particular medium to that produced in a vacuum or a free space, that is B0. So here we are going to divide the magnetic flux density of two medium. Here we are dividing magnetic flux density in a particular medium divided by produced in a vacuum or a free space. So here we are dividing B divided by B0. So due to this ratio we can find the relative permeability. By the same magnet we have to take the values of B and B0. By the same magnet, how much magnetic flux density is there in particular medium and how much magnetic flux density in a vacuum we should calculate for the same magnet. So relative permeability is mu r, and it is the ratio of B in a particular medium to the B in a free space. This is nothing but the relative permeability. So but from these formulas we can calculate the mu r. So here mu r is equals to B upon B0, but we know that B is equals to mu H and mu naught is equals to B naught is equals to mu naught H. So while putting these values of B and B naught in above equation, we get mu H divided by mu naught H. So here H is common, so we can cancel out H in numerator and in denominator. So what remains? Mu divided by mu naught. That means we can modify this formula for mu is equals to mu naught into mu r. So here what is mean by this? The permeability absolute permeability is equal to the product of relative permeability and the permeability of free space. Here the value of permeability of free space is always constant, and it equals to 4 pi into 10 raised to minus 7 Henry per meter. So you should know this value of mu 0 for solving the numericals. So you will get numericals on these type of formulas. This is what relative permeability. What is next definition? Magnetomotive force. So what is mean by magnetomotive force? In before I have discussed one formula of magnetic field strength, it contains the mmf. So I said you, so we will learn in further. So here magnetomotive force is nothing but the mmf, and is the force which is responsible for flow of magnetic flux through in a magnetic path or circuit is called as a magnetomotive force. This is the force responsible to flow फ्लो ऑफ मैग्नेटिक फ्लक्स, मीन्स जो फ्लक्सेस एन पोल टू एस पोल की तरफ जा रहे हैं, तो ये फ्लक्सेस को मूव करने के लिए जो फोर्स ज़रूरी है, जो फोर्स रिक्वायर्ड है, जो फोर्स रिस्पॉन्सिबल है, दैट फोर्स इज कॉल्ड एज अ मैग्नेटोमोटिव फोर्स. तो मैग्नेटिक सर्किट या फिर पाथ में मैग्नेटिक पाथ में जो फ्लक्सेस यहाँ से वहाँ जा रहे हैं, फ्लो हो रहे हैं, these fluxes are responsible to flow in a magnetic path or circuit due to the force called as magnetomotive force. तो इसी फोर्स की वजह से फ्लक्सेस एक एन पोल से एस पोल की तरफ जा रहे हैं. सो इट its unit is ampere turn. So mmf का unit जो होता है, mmf is nothing but the force. That's why we can write here mmf equals to force, and this always equals to n into I. Here number n is nothing but the number of turns and I is the current. So what is next definition? Reluctance. Reluctance symbol, or it is denoted by capital S. So what does this mean? Reluctance means is the property of magnetic material which opposes the setting up of magnetic flux in it, is called as reluctance. So do you remembering that point we have studied in a very first chapter? We have seen a resistance, and resistance is nothing but the property of a conductor which opposes the flow of current. In electrical circuit there is resistance, whereas in magnetic circuit there is the magnetic material have the property which opposes the setting of fluxes. This property is called as a reluctance. That means these two are analogous to each other. That means in electrical circuit there is resistance, whereas in a magnetic circuit there is reluctance, and the property is same. They opposes the flow of, here in resistance it opposes the setting up of current or flow of current, while in magnetic circuit these this type of reluctance is nothing but the property which opposes the setting up of magnetic flux or magnetic field in it. So as we can calculate by formula, S is equals to K into L divided by A. Here K is nothing but the constant, L is the length, and A is the area. But K is equals to, K is always equals to 1 upon mu. So here mu is nothing but the permeability. Therefore we can put the value of mu. By putting the value of K, we get the formula S is equals to L divided by mu A. Therefore, we know that mu is equals to mu 0 into mu r. So while putting value of mu, we can write the formula of reluctance as S is equals to L divided by mu 0 into mu r A. So whenever you have to calculate the value of reluctance, so you should take there are three formulas for calculating S. On depend It depends on the given part, so values of which values are given, from on the basis of that you could take the formula from reluctance formulas. So there are three formulas, so from these formulas you can take the respective formula on the basis of given part. So the last definition in the magnetic circuit is related with the permeance. So permeance is nothing but the reciprocal of reluctance. As in electrical circuit there is resistance, and reciprocal of resistance is nothing but the conductance. In parallel circuit, yes, we have seen in a dual comparison, we have seen in earlier section. In parallel circuit there is a parameter, or in a very first chapter we have seen about the conductance, and conductance definition is reciprocal of resistance. So these things are related with electrical circuit, where in a magnetic circuit there is reluctance, and reciprocal of reluctance is called as permeance. Permeance is nothing but the ease of flow of magnetic fluxes through the magnetic material. So this is the property of magnetic material which makes ease of flow of magnetic fluxes. That means it allows the magnetic fluxes to flow easily through it. So this permeance is equal to 1 upon reluctance, and its unit is Weber per ampere. Weber per ampere. So I hope you get all the definition in magnetic circuit, and it will help you in your further studies. Or in numericals, you can solve numericals on the basis of this magnetic circuit numericals you can solve easily. So I hope you study, I hope you understand well about magnetic circuit. So you understand magnetic circuit. Thank you.